sixth graders. Happy Thursday. Welcome to lesson 12. I can't believe it, our 12th lesson within Unit 7. All of that has been covered in online classes. Super impressed as always with your work and really excited to dive into our lesson today. We're still working today on the coordinate plane. And so we're going to continue building on what we learned yesterday. Remember, yesterday we talked for the very first time about the coordinate plane, not just with positive x values and positive y values, as we saw in elementary school, but also knowing that this is just a number line, and now we know negative numbers exist to the left of 0 or below 0. Now we can write ordered pairs with both positive and negative values, which is really exciting. Let's go ahead and set up our notes. Today is Unit 7, Lesson 12, Constructing the Coordinate Plane. The first thing that I'm going to ask you to do is take a look at this diagram. I think it's really helpful just to review what each quadrant is, as well as what kind of ordered pair goes in each one. So for example, here in quadrant 1, if I have a positive x value and a positive y value, my point will end up in quadrant 1. So that's why in the x position, you see a plus sign for positive, and in the y position, you also see positive. In quadrant 2, this little diagram shows me that if I have a negative x value, but a positive y value, then my point ends up in quadrant 2. In quadrant 3, I would need to have a negative x value and a negative y value for a point to end up here. That's because this quadrant is to the left, of 0, and it is below 0 or below the origin. So if this is true, then your point will end up in quadrant 3. And in quadrant 4, that's when I have a positive x value and a negative y value, okay, to the right of 0, but also below. That's what this symbol is for. Notice, what's the difference between quadrant 2 and quadrant 4? Hopefully you saw the difference was that the ordered pair signs are opposite order. So in quadrant 2, the x value is negative and the y value is positive. In quadrant 4, it's opposite. The x value is positive, the y value is negative. Please take a second and write down this, the version of this picture onto your notes. I've pre-written it here just so you can see the kind of thing I'm looking for. It does not need to be perfect, but I do want to see quadrant 1, 2, 3, and 4. Remember, those are Roman numerals, as well as what kind of ordered pair goes in each one. You could give yourself a note about which axis is the x and which is the y axis. That can be really helpful too. Awesome. If you need more time than that, please pause the video and finish up this section of notes before continuing on. All right, we are going to talk today about, given some data, what should our graph look like? Or given an ordered pair, where might it be on the graph and how should I set that graph up? So here is some data from an English, oops, it just went away, from an English winter. It says the following data were collected over one December afternoon in England. Here's time. I'm noticing this is positive. These are all positive numbers and 0, and it goes up by 1s, so every hour. And here is temperature in Celsius. I see some positive numbers. Looks like the temperature is dropping. It is getting what, warmer or colder? As time afternoon increases, it looks like it's getting colder. The temperature is dropping all the way to -4 degrees Celsius. This does not look like a proportional relationship to me, and that makes sense. Weather sometimes is often unpredictable and doesn't follow that proportional relationship. Okay, answer this question. Number 1, which set of axes would you choose to represent this data and explain? I also want you to answer question 2. 1 minute to do that. Time starts now. So when you're choosing your axes, I want you to think of the values within the table as like an ordered pair. So this first row in my table, 0, 5, is the point 0, 5. So an x value of 0, a y value of 5. Then the ordered pair 1, 3. Start thinking about some of these negative numbers as well. Choose axes that make sense to you. Awesome. If you need more time, please pause the video. If you're ready to go ahead and follow along with me. All right, I chose B. Did you choose B? If you chose B, go ahead and put a star on your paper. When you upload your notes, I love seeing all of those stars on your paper, so really nice job. I chose B for one big reason, and that's because of the scale on the axes, and that's how much each box is worth. Okay, here's what I wrote. I would choose B because the data includes positive and negative y values between 5 and -4. It would make sense to count by ones or twos on the axes. So I've got to look really carefully. Let me zoom in even here. I want to look really carefully at my axes, and I'm noticing that every one of these boxes must be worth 1 because 2 of the boxes is worth 2. Same thing on my y-axis, okay? In A, we're just counting by ones. In C, we're counting by tens, okay? Additionally, I'm noticing that I need to go into the negatives for my y values. So if I look at B, I know my y values do go into the negatives. In C, that happens as well, but skip counting by tens doesn't work very well because these numbers are all closer to 0 than 10 and -10 are. These are all smaller than a positive 10. So I could plot these points, but they'd all kind of fall in between right here. So it doesn't make very much sense to use a scale like C. Why is A not appropriate? I hope you said A is not appropriate because I can't get to my negative y values here. This is a coordinate plane like you would see in elementary school before you knew about negative numbers and where they would fall on our number lines. And I can't plot those negative temperatures. So this might be good for a different question, but it's not good for this question. Please pause here and go ahead and answer in your Google form. Answer question 1, which of those axes is the most appropriate? Awesome, you should have selected B. All right, we're gonna move on. I know I say I'm excited a lot, but I am truly excited. I was playing with this for a while before I was ready to film this lesson, and I'm really excited for you to give it a try. What we're gonna practice now is plotting and then naming points on the coordinate plane, including in all 4 quadrants, okay? So here's what we're gonna do. I'm going to read this question to you, and I'm going to model how to use the tool, and then I'm going to give you, I think 6 minutes is appropriate, maybe 6 minutes to try this out before we come back together, okay? But first, listen to the instructions. Here is a maze on a coordinate plane. The black point in the center is 0, 0. The side of each grid square is 2 units long. So check it out. Here's that point, that black point in the center is 0, 0. That's called the origin. That's called the, yeah, you knew that already. Where is quadrant 1? Go ahead and put your finger on the screen. Where's quadrant 1? Yep, quadrant 1 is over here, right? Positive x values and positive y values. I can see this corner point up here has an ordered pair of 10, 14. That is because it says the side of each grid square is 2 units long, 2, 4, 6, 8, 10, so an x value of 10, and a y value of 2, 4, 6, 8, 10, 12, 14. Okay. Same thing, I can see this point over here, so if I want to go negative x values and positive y values, I've got to make sure to include that in my ordered pair, quadrant 3 and 4. Okay, so what are we doing? We've got to solve the maze. That's what we're going to do in this activity. So you are going to, or you already have, entered the above maze at the location marked with a green segment. That's right up here. You are going to, in a second, draw line segments to show your way through and out of the maze. You're going to label each turning point with a letter. I'll show you how to do that on the computer. Then list all the letters and write their coordinates. Okay. I'm so excited. In just a second, you're going to click on this link. Please don't do it yet because I want to show you how the tool works, okay? You are going to click on that link and it's going to open this maze for you. The first 3 points are already given. I'm going to start here. The finish line is all the way down here. The finish line is all the way down here. So if I want to get through the maze, I need to go, I need to pick up at C. In order to draw points, I use this tool up here. So let's say I want to maybe go down to here. I'm going to click and make sure my point tool is highlighted. I'm going to click and it's going to label the next letter in the alphabet. If I make a mistake, I can just use this undo button or the garbage can. Let's say after I go down here, I want to turn this way, and then I want to go back up, and then I want to go, I don't know, over, right? You might want to plan out the maze before you start doing this. Then I'm going to connect with a line. So I'm going to click my segment tool here. And to do this, I need to click 2 times. How many times? Yeah, I'm going to click the start point and the end point. And when I do that, I've got a line. And my segment tool is still highlighted, so I don't need to come back up here and click it. I'm just going to keep going. Click the start, click the end. Click the start, click the end. If I don't click the end, it looks like this, right? Click the end. Okay. Once I am done, I will have landed all the way over here at the finish point. That is your goal, to be there in just a few minutes from now. The other thing that you need to do on your paper is go ahead and set up a label for question number 3. And what I want you to do is list out the ordered pair. Oops. Mr. Ortega is calling me. He's going to have to wait. I want you to list out the points as well as the ordered pairs. So let's see, I did this one ahead of time. A is at negative 11, 9. All right, folks. Go ahead now and click the link underneath the video. I will put a timer for 6 minutes. Keep your sound on so you can hear me when we're ready to go. All right, 6 minutes are on the clock. All right, so we are about 2 minutes in. You should have put all of your points all the way to the finish line and be working on connecting them with those line segments. All right, team, we are about halfway through our time. Make sure at this point that you are starting to write down the letters on your paper and write down the ordered pair of that lettered point. For example, A is at -11, 9, because it has a negative x value of -11 and a positive y value of +9. Go ahead and try that now. There's about 1 minute remaining, so you should be working on writing down those ordered pairs on your paper. All right, folks, we are wrapping up our time. Maybe you are still finishing up your ordered pairs. So if you need a second to finish that up, please come on back over to this tab and pause the video so that you don't miss what's coming next. Awesome. If you are watching now, it means you have completed the maze in the applet and you have written the ordered pair for all of the points that you used in your maze, okay? I am now going to show you my solution. Keep in mind there are many ways to complete the maze. So your letters might be in a different spot than mine, and you still might be correct. So keep that in mind. Let's see here. Yep, awesome. Here is my solution. And I want to show you also my points, okay? All right, a few things to keep in mind. The most important part of this activity was not, can you find your way out of a maze? The most important part of this activity was not, even though this is important, but the most important part was not, can you use these tools correctly? The most important part is absolutely that you are able to write an ordered pair of a point you see on a coordinate grid, okay? So I just want to review a couple of tips for doing that. Here is, let's see, I'm going to make this green. Here is what we might call, it's really hard to do a straight line like this on my computer. I'm sorry, I know this looks crazy. Here is a y-axis, and here is my x-axis. Okay, cool. That's helpful. I see I put the origin at the middle. Now I can see my quadrants, quadrant 1, 2, 3, and 4. So for me, the example I showed you is a little different than this, but for me, I went out straight this way, and so I put a point right here. When I'm thinking about the value of this point, I'm thinking about what's the scale on my axis. I know because it said in the question, and I know because of this, that each box is worth 2. Each box is worth, yeah, so halfway through a box is worth 1. So the x value for point D has a value of 1. So then you can see in my ordered pair way over here, for point D, I have an x value of 1. And then I'm going up, up, up. That means it is positive. All the way to D, I go 2, 4, 1 more, 5. Okay. E has, interestingly, the same x coordinate, right? I still am only going 1 over, and this time I'm going 3 up, right? Here's that ordered pair. Cool. I came down in my maze. I just want to talk about point G really quickly. It's very likely that you have a point in this same position. And I want to talk about its ordered pair. This point, does it have a positive x value or a negative x value? Remember, x is left or right. G is to the right of 0, so it has a positive x value. I go from 0 to a positive number. That is 2, 4, 6, 7, positive 7. And then does G have a positive or a negative y value? Remember, y is up and down. G is below 0, so G has a negative y value. Its y value is negative 2, negative 4, negative 6, negative 8, negative 9. So my ordered pair for G is 7, negative 9. All right, the last part to review here is you have a finish point. It might be labeled with a different letter, but it is here at this point. You are going to go ahead and record the ordered pair for point, for me, point K, for you, whatever your finish point is at this location. So I can see starting at the origin, I go to the left, my x value is negative 2, negative 4, and then one more, negative 5. Negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14. Okay, so for K, this is question 4. There we go. What is the ordered pair of the finish point? Go ahead and select your answer for question 4 now. Awesome. You should have selected C. C, negative 5, negative 14 is the finish point of this maze. Okay? Awesome. We're going to review the lesson summary, and then I will give you your question of the day. Take a look at our lesson summary, please. The coordinate plane can be used to show information involving pairs of numbers. When using the coordinate plane, we should pay close attention to what each axis represents, what each axis, and what each scale uses. Scale is what are we counting by. Suppose we want to plot the following data about temperatures in Minneapolis one evening. Time is typically our X values, and the other data is usually our Y value. So I'm noticing that actually both are positive and negative. Got negative numbers in both and positive in both. We can decide that the x-axis represents the number of hours in relation to midnight, and the y-axis represents temperatures in degrees Celsius. In this case, x values less than 0 represent hours before midnight, and x values greater than 0 represent hours after midnight. On the y-axis, the values represent temperatures above and below the freezing point of 0 degrees Celsius. Okay. The data involve whole numbers, so it is appropriate that each square in the grid represents a whole number. So notice the scales here are chosen to be 1 on both the x-axis and the y-axis. To the left of the origin, the x-axis needs to go as far or less, farther to the left, as far as -4 or less, sorry. My farthest to the left point is at -4. And on the right, my farthest to the right point is only 3. Okay, so you can include more than that, but you can't include fewer than that. Below the origin, the y-axis has to go as far as -8 or lower, and it needs to go to at least +3. Okay, here's that graph. On this coordinate plane, the point as 0, 0 means a temperature of 0 degrees Celsius at midnight. The point -4, 3, let's find that. -4, 3 means a temperature of -3 degrees Celsius at 4 hours before midnight, which is 8 p.m. Okay. Lots of really great practice today in all 4 quadrants. Here is your question of the day. The question of the day is happening right now. I'm going to go ahead and put the question of the day on my notes. I want to know, in what quadrant would you find the point -6, 3? In what quadrant would you find the point -6, 3? I would flip back to your notes at the very beginning and figure out which quadrant would hold that point, -6, 3. Go ahead and choose your answer now. If you said quadrant 2, you are correct. The answer to the question of the day is quadrant 2. Awesome. Go ahead and make sure that is answered. Upload your notes if you are able to do that. I love to see the stars on your paper and all of your thinking. And you can also earn Vista points for doing that. So take that extra step if you're able to do that with your technology. You have an independent practice assignment to complete on the next page, as well as a skill builder. I think that's it for me. You guys, great job. Oh, one other thing. If you want an extra Vista virtual point, upload a screenshot of your maze. I'd love to see it. Bye, guys.